What force does a car exert if its mass is 1,201 kilograms and the car goes from 5.4 meters per second to 13.6 meters per second in 107 meters? All right, I'm going to start with a little drawing here. So here's my car, quick little car, and then over here is going to be my car. There we go. Let's see, it's going to travel 107 meters this way. 107 meters. It's going to start at 5.4 meters per second. And over here it's going to be 16.3 meters per second. And I know the mass. So the mass is going to be 1,201 kilograms. All right, let's switch gears for a minute. Get started with a list of givens. So here are my givens. Let's see, the beginning of my little motion, the beginning of my story, my picture, V naught, is equal to 5.4 meters per second. Final velocity is the end of my motion, or the end of my story, 16.3 meters per second. And the distance it travels is a displacement of 107 meters. And I know the mass is 1,201 kilograms. Let's see, and I'm looking for the force. All right, so what I know about all this is that the force is found from F equals ma. Well, that's great. I got the mass. I'm looking for the force, but I don't have the acceleration. But I do have these kinematics variables. So with those three kinematics variables, I can find the acceleration. So now I'm looking for a kinematics equation or relationship that has v, v naught, x, and a in it. So that's the one without time. That's going to be the v squared equation. So what I'm going to do is I'm going to find the acceleration using kinematics and then use Newton's second law to figure out what the force is going to be. So let's start with kinematics. V squared equals v naught squared plus 2ax. All right, I'm looking for the acceleration, so I'm going to isolate the unknown. I'm going to subtract v naught from both sides. Let's see, I'll go ahead and kind of fudge this stuff on the other side for a moment here, just because I got ahead of myself. 2ax. So now if I'm isolating a is equal to final velocity squared minus the initial velocity squared, all that divided by 2x. So a is equal to the final velocity, 16.3 meters per second squared, minus the original velocity, which is 5.4 meters per second, and that's all squared. All that divided by 2x, so that's 2 times 107 meters, or 214 meters total. And when I do that, I should get an acceleration of let's see, oop, that's wrong. Got ahead of myself there. 1.10528.0374 meters per second squared. And I would store that in my calculator because my next calculation I want to use all these decimals. A little note about the calculation. So on your calculator, what you would probably write is the numerator in parentheses, so we can do it all in one step, 16.3, and that would be squared, minus 5.4 squared, parentheses, and then the denominator in parentheses again, 2, and then on the calculator it has a little asterisk, so I'm going to go ahead and do that, asterisk times 107, and that's going to give me the 1.1052. If you didn't get the 1.10528.0374, without those bottom parentheses, what it will do is it'll take the number it gets in the top, multiply it by, divide it by 2, and then multiply that number by 107. That's not what I'm intending. So these parentheses in the order is very important. Back to the problem. I'm looking for the force. So that's F equals ma. So my force is equal to the mass, 1,201 kilograms, times the acceleration, 1.10528.0374 meters per second squared. So that's going to give me a force of 1327.44 and some other decimals newtons. Now to 3 sig figs, that would be F is equal to 1330 newtons.